Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams. Welcome. This is the June 2013 Caribbean Exam CXC CSEC General Paper 2 video solutions. Let's start with question 1. Now part 1 tells us to find the exact value of this expression. So what we have is an expression with mixed numbers or mixed fractions, and we have this term on the numerator and this term on the denominator. And so we are dividing this expression on the numerator by this expression on the denominator. So what we can do is break out these mixed fractions and express them as whole numbers and proper fractions. And this is it. This term here, 1 and 4/5, is the same as 1 plus 4/5, and then we are subtracting 1/3, and then we are dividing that expression by this. 2 and 2/5 is the same as 2 plus 2/5, and we can write this 1 as a fraction as 1 divided by 1, and we can write this 2 as a fraction, 2 divided by 1. So we'll be dealing exclusively with fractions. So let's show that. So this is it. This is now 1 over 1 is 1 plus 4/5, that's this term here, minus a third, minus this third, and then we are dividing by 2 and 2/5. The 2 here is written as 2 divided by 1 plus 2/5, plus 2/5. Now what we want to do is add these fractions and also add these fractions. So we form one term here and one term here. Now when we add fractions, our aim is to make the denominators the same. And based on these three denominators, 1, 5, and 3, the lowest common multiple of 1, 5, and 3 would be 15. And here, the lowest common multiple of 1 and 5 would simply be 5. So we can adjust each of these fractions so that they all have the same denominator. So for this term, we would multiply this denominator by 15, so it becomes 15. And so we would also have to multiply this numerator by 15. So this 1 divided by 1 really becomes 15 divided by 15. For this term, we would multiply this denominator by 3, and that will become 15. And we would also have to multiply the numerator by 3, and so the numerator will become 12. Here, we will multiply this denominator by 5 to make it 15, and so we would also have to multiply this one here by 5, and so this becomes 5. And in this case, we will multiply this denominator by 5 and also multiply this numerator by 5. So this becomes 10 divided by 5, which still would be 2, and then this fraction, 2 divided by 5, would remain as 2 divided by 5. So let's show that. So this is it. This term becomes 15 divided by 15. As I said, we multiply numerator and denominator here by 15. This term becomes 12 divided by 15 because we multiply numerator and denominator by 3. And this term becomes 5 divided by 15 because we multiply denominator and numerator by 5. And here, this term becomes 10 divided by 5. We multiply denominator and the numerator by 5. And this term remains 2/5. So now that all the denominators here are the same, we can add the numerator, and here the denominators again are the same, and so we can add these two numerators. And when we add, it becomes 15 plus 12, that's 27. 27 minus 5 is 22. So inside this bracket, we're going to end up with 22 divided by 15. And here we add 10 plus 2 is 12, all divided by 5. And so our expression reduces to this. The terms in this bracket add to 22 divided by 15, and the terms in this bracket add to 12 divided by 5. And so remember, when we divide fractions, we multiply by the reciprocal of the dividing fraction. And so this becomes 22 divided by 15, that's from this term, and then we multiply by the reciprocal of 12 divided by 5, which is 5 divided by 12. So 22 over 15 divided by 12 over 5 is the same as 22 over 15 multiplied by 5 divided by 12. And now here, all we need to do is simplify these terms. And so the 22 and the 12 here, each of these can be divided by 2. So 22 divided by 2 is 11. 12 divided by 2 is 6. And here, this 5 and this 15 each can be divided by 5. And so we simplify. The 5 divided by 5 is 1. And the 15 divided by 5 is 3. And now all we need to do is multiply 11 by 1 and 3 by 6. 11 times 1 is 11 and 3 times 6 is 18. And so our result is 11 divided by 18. And that's the answer for part 1 of question 1A. Let's move down to part 2. In part 2, we are told to find exact value of this expression. So what we have here is the square root of this number plus the square of this number. And what is important here is that we do the addition last. So we need to find the value for this expression and then square this term and find the value for this expression. Get those two numbers separately first and then add the result of those two operations. So let's go ahead. And so the square root of 1.5625 is 1.25 and the square of 0.32 is 0.1024. And now we can proceed by adding these two numbers, and when we do that addition, the result is 1.3524. So that's the exact value of this addition, and that's the answer for part 2 of question 1A. Let's move down now to part B. Now in part B, we are told that orange juice is sold in 2 differently sized cartons, and we are given the table showing the price. So in this first carton, the volume in this carton, which is the smaller of the 2 cartons, is 350 milliliters, and that is sold for $4.20. This larger carton contains 450 milliliters, and that one is sold for $5.15. And we're required to determine which of the 2 cartons is the better buy.
Okay, so I've just stopped the video to explain another way of doing this question. It's a method that I've been using in class, which is different from the method that is explained in this video. So I will break and explain this method, which I've been using in class, and then I will continue with another method that I used for the video previously. So in this method, to determine the better buy, what we say is that we want to see how much we are getting for $1. So it's a matter of making the comparison for each of the cartons and see how much of the juice in each carton we are getting for $1. And so the one that we are getting more juice for $1 would be the better buy. And so if 350 milliliters is sold for $4.20, all we need to do is divide this as a ratio by 4.20 to see how much juice we would get for $1. Similarly, for the 450 milliliters, which is sold for $5.13, all we need to do to see how much juice we get for $1 is to divide by the 5.13. So let's show that calculation here. So here I'm going to show the calculation for the amount of juice in milliliters per $1. Now for the 350 milliliters carton, as I have said, all we need to do is divide the 350 milliliters by 4.20, and that will give us the amount of juice for $1. And basically this is it. When we divide, we see that we are getting 83.3 milliliters for every $1 in the 350 milliliters carton. And when we do a similar calculation for the 450 milliliters carton, by dividing the 450 by 5.13, we see that we are getting 87.7 milliliters for every $1. And clearly, the 450 milliliters carton is the better buy because we are getting more juice for $1 as compared to the amount we are getting in the 350 milliliters carton. So as a summary, to give the explanation, what we are saying is that we are getting 83.3 milliliters for each $1 in the 350 milliliters carton, while we are getting 87.7 milliliters for each $1 in the 450 milliliters carton. And so that concludes that we are getting more juice for each dollar in the 450 milliliters carton, and therefore the 450 milliliters carton would be the better buy. We are getting more juice for your dollar. Okay, so this is an explanation I've been using in class, or a method that I've been using in class. And so I'll just continue the video with the original method, but feel that this method is a easier method for the students to understand. And so it's a method that I've been using recently. Alright, so I'll just continue with the video, and students can choose to use whichever method they prefer, but I believe this one is easier to explain. Alright, so let's continue with the video.
So to determine which carton is a better buy, we need to work out the unit price for the orange juice in the smaller carton, and also the unit price for the orange juice in the larger carton. So if we can find the cost for 1 milliliter of orange juice from the smaller of the two cartons and compare that with the cost of 1 milliliter of orange juice in the larger carton, then we'll be able to compare the two cartons and see which is the better buy. So let's show what we have to do. We have to calculate the cost per milliliter in the two cartons. And because we'll be dividing by the 350 here and also dividing by the 450 here, it's better we work in cents. Instead of using, for example, the $4.20, we can convert this to 420 cents and then do the division. And here we convert the $5.13 to 513 cents and then proceed with that division. Let's go through the steps. So here we want to calculate the cost per milliliter, and as I said, we're going to give the values in cents per milliliter. So the cost here is written as 420 cents and the cost here is written as 513 cents. And so the cost per milliliter for the smaller carton is calculated by dividing the 420 cents by the 350 milliliters, and that's going to give us the cents per milliliter in the small of the two cartons, and that works out to 1.20 cents per milliliter. That's the cost of 1 milliliter of juice in the smaller carton, 1.20 cents. For the larger carton, we are dividing the 513 cents by the 450 milliliters, and that calculation gives us 1.14 cents. So the cost for 1 milliliter of juice in the larger carton is 1.14 cents, and we see that this value is smaller than this value. And so to write the result, each milliliter of orange juice in the 350 milliliters carton that's in the smaller carton costs 1.20 cents, while each milliliter in the 450 milliliters carton costs 1.14 cents, and therefore the larger carton is the cheaper in terms of the per milliliter cost, and so the larger carton is the better buy. It is better to buy the 450 milliliters carton because we are paying less for each milliliter of orange juice, and that's the answer. The larger carton is the better buy. Now let's move down to part C. Now in part C, we are told that $9,600 is borrowed at 8% per annum compound interest. Now compound interest means that the interest is charged on the balance outstanding for the period and not just on the principal. If it was a simple interest arrangement, then the interest would be charged only on the principal. And the first part of this question wants us to calculate the interest for the first year, and the interest for the first year is simply 8% of the amount that was borrowed, and that calculation gives us $768. So 8% of $9,600 is $768, and so this is the interest amount charged on the $9,600 at the end of the first year. That's the first year's interest. And so the total amount owing at the end of the first year is the $9,600 that was borrowed plus the amount accrued as interest. And that total amount owing is $10,368. This information is relevant to proceed to the next section. So we are told that $4,368 was repaid at the end of the first year. So the total owing at the end of the first year is $10,368. That's the principal amount plus the interest for the first year. That's this figure here. And $4,368 was repaid at the end of the first year. So therefore, the balance owing at the start of the second year, that's what we're required to show now. The balance owing at the start of the second year will be equal to the total amount owing minus the amount that was repaid. And this is the calculation: the total amount owing, which is this figure here, minus the amount repaid, that's here. And when we do that calculation, the amount owing at the start of the second year, which is equivalent to the end of the first year, is $6,000. And then part 3 now wants us to calculate the interest in the second year. So since $6,000 is the amount owing at the start of the second year, then the interest will be charged on this amount, the amount owing at the start of the second year. So the interest at the end of the second year will be 8% of this balance owing. And that calculation is simply 8%, 8 divided by 100 multiplied by 6,000. And the result of that calculation is $480. So $480 is the interest at the end of the second year. That's the second year interest, 8% of $6,000. And that's the answer, $480. Okay, so that's the end of question 1, and we'll do question 2 in the next video. See you then. You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.